Folks, what type of function is this? Absolute value. So first, check yourself and make sure that your graph looks like a V. Parent table, negative 1, 0, 1, 1, 0, 1. And I'm going to go ahead and plot those. And we see that we have this happy V. Now, transformation-wise, what is going on to this function is we've got a plus 4 on the inside, which is moving us left 4. Left 4. And then what's that 2 out in front doing? Vertical stretch by 2. So my x values will be affected by the left 4, and to move them 4, we are going to take x values minus 4. So it's plus 4 in the equation, minus 4 in the transformation. Then to vertically stretch by 2, is it y plus 2 or 2 times y? 2 times y. It's 2 times in the equation. It's 2 times in the transformation. So let's go ahead and make that lovely transform table. So if I subtract 4 from each of those x values, we get negative 5, negative 4, and negative 3. If we double all those y values, we get 2 and 0 and 2. So let's go ahead and plot our transformed function. Backwards 5 up 2, backwards 4 up 0, backwards 3 up 2. Swoosh, swoosh. Does our graph match what we said for our transformations? Does it look like we moved left 4? And folks, that's important because if you use a plus 4 here instead of a minus 4, your graph is going to shift over in the other direction. So as kind of a final check to yourself, always make sure that what you have here matches with what you described. Because I think you guys are really good at describing the transformations, but I think doing the table stuff is sometimes a little bit harder. And what about vertically stretching it? Does it look like we took that blue graph and pulled on it vertically? Yep, to make it narrower, looks good. So from here, we are ready to state the domain and the range of the pink function. I'm going to give you a minute to try those. So ignore the blue function, just domain and range of the pink one.
Hello everybody, my name is Mark Conchai.
Go ahead and check yourself. Domain is all real numbers. X values that get covered by this function is everything because we can plug whatever X we want in for that number washing machine. Those arrows on the graph go all the way left and all the way right. So all real numbers get covered. In interval notation, that would be negative infinity to infinity. Now the range, we never get to any y values below that vertex. So our y values start at 0 and we are covered going up. So y greater than or equal to 0 or bracket 0 infinity. How'd we do on that one? Raise your hand if you were exact on the money or pretty close. That was pretty close. All right, turn the page. Now on this page, we are trying to write the function from the graph. So let's just talk about the shape of these first. The shape of number 9 is a what? It's an upside down U. So that is a quadratic, which has the parent equation y equals x squared. And it looks like that U. So we want to try to figure out what transformations have been brought upon this quadratic. I normally look at the shape first. Does it look like this has been vertically reflected? Yup, because it is upside down. So a vertical reflection has definitely occurred. Does it look like it has been stretched or shrunk at all? The slope, quote unquote, between my central point and the next point is down one, forward one. The negative simply indicates that there was a vertical reflection, so it hasn't been stretched or shrunk at all. Next thing we look at is sliding transformations. Our original vertex is at 0, 0. Where has my new vertex slid to? 1, 2, 3. Down 3. So now, folks, we have 2 transformations, down 3, vertical reflection, and we need to put those descriptions back into the equation using numbers. So a vertical reflection is going to be a negative on the outside of our function. So negative x squared. How am I going to say down 3? Minus 3. And why is this not right? I heard someone say it. What else do we need? Y or f of x. Either is good, but folks, this needs to be an equation. It's a little detail, a fussy little detail, but we want to be fussy here. We want to make this an equation. Folks, any questions on that one? All right, numero 10. What type of function is this? Square root. Which looks like y equals square root of x. It starts at the vertex at 0, 0 and swooshes to the right. So first thing we check for is vertical reflection. Has this been vertically reflected? No, because if it was vertically reflected, it would be curving down. So no vertical reflection. What about a stretch? We look at the vertex point to the next point, slope, and we see that we are going up 1 and over 1. So slope is 1, nothing stretchy or shrinky happening here. Next are sliding transformations. We have started at 0, 0 and gone forward 2, up 3. So up 3 and right 2. So f of x equals, and we need to turn these descriptors up 3 and right 2 back into our equation with numbers. So the plus 3 is going to be outside our square root. So I'm going to draw my square root and do plus 3 over there. Now right 2, that's going to be inside my square root. That's those inside transformations. Will that be x plus 2 or x minus 2? X minus 2. And folks, we are a lot more used to looking at this and describing it as right 2. So after you write it, cover this up and say, hey, does this make sense with what I know about transformations? Negative 2 on the inside, we cross our eyes. It is the opposite of what we would expect with the signs. So that would move it right 2. So folks, do we have any questions on those 2? And again, I just wanted to hit all that stuff again based on how the homework quiz went yesterday. The next thing we're going to practice a bit more, and this is what your homework quiz is going to be on today. So homework quiz 2B. This is a throwback to what we did yesterday and a little bit the day before. We are going to do our domain and range. Domain is x values, range is y values. So where do my domain values start for this fancy little graph? Do they start at -1? Do I map to anything on my function at -1? Nope. The first x value that we get is 0. And then we can get a value of 1, a value of 2. You can color this if that made more sense on the previous page. But notice that all of those x values are getting covered, and then we have a very abrupt stop at what x value? 7. So we start at 0 and we go to 7. As a sandwich statement using inequalities, we would say x is greater than or equal to 0, or 0 is less than or equal to x, and x is less than or equal to 7. Or using interval notation, bracket 0, 7 bracket. I personally like the interval notation better. I don't really like writing those sandwich statements. I know that sometimes students get confused with which direction the inequality signs are going to go. So if you want to jump around between how you express it, sometimes do inequalities and sometimes do interval notation, that is all good too. So let's talk our range on this one. Looking at my y-axis, do I get -3 anywhere? Nope. Do I get -2 anywhere? Yep. Right there on my graph. And then we get -1 and 0 and that value and that value. And then my y values stop up here at 4. So we start at -2 and we stop at 4. Using interval notation, -2 to 4, making sure you go from negative to positive. Using sandwich statement notation, -2 less than or equal to y, less than or equal to 4. The other thing that sometimes students will miss with inequality notation is using the proper variable. Domain is x, range is y, so you gotta make sure you're using the proper variable there. Folks, is this a function? Yes, because it passes the VLT. If I put a vertical line up, it is always only hitting the graph in one spot, never going to hit in 2 spots at the same time or having doubles. Is this a one-to-one function? Nope. So if I put up a horizontal line, we're hitting the graph in more than one spot, so that's a no. All right, folks, on your own, I want you to try number 2. Domain for this one, either x is greater than or equal to -2 since it starts at -2 and is covered going to the right. The range starts at -1, so y is greater than or equal to -1, or -1 with a bracket, infinity, parenthesis. Is it a function? Yup, it passes the vertical line test, and we know that square root functions are one of our 5 basic functions, so yup, it's a function. Is it one-to-one? Also yes. All right, folks, so I hope that this helps you feel a bit more confident on the first 2 sections. There is a lot in there, especially with memorizing the parent functions and the parent tables. If you want to make your own flashcards for that, you might find that very beneficial. But again, the square root one is the only one with a unique set of inputs. Learning your transformation rules and how you apply them to the table. Be very careful with your x transformations. So what we are going to do next is we're going to take a homework quiz. I would like you to clear everything off your desk.